We can use the fact that roots and exponents cancel, with that note in mind about the absolute value when we take an even root of an even power, to simplify expressions where we have a root of a variable. So let's say we want to take the third root of x to the 18th. We can notice that this number 3 is a factor of 18. In fact, 18 is equal to 3 times 6. So x to the power 18, that's x to the power 6 times 3, which we can write as x to the power 6 to the power 3, using that power of a power rule. And so the third root of x to the 18th is the third root of x to the 6th to the third. And now we can cancel the third root and the third power, and we're just left with x to the 6th. And notice that we do not need an absolute value because the number 3, the index of our root, is odd. If we're taking an odd root of an odd power, we do not need an absolute value. Next, let's simplify in the similar way the fourth root of x to the 20th. Now, 4 goes into 20. We notice that 20 is 4 times 5. So x to the 20th is x to the power 5 times 4. Using the power of a power rule, that's x to the 5th to the 4th. And so we can take the fourth root of x to the 5th to the 4th. The fourth root and the fourth power cancel, and we're left with x to the 5th, but we do need an absolute value because the number 4, the index of our root, is even. Now this absolute value x to the 5th means make x to the 5th be positive. We could also say make x positive and then take the 5th power. Either one of those is correct. You can put the absolute value around the x to the 5th, or you can put it just around the x, whichever is more convenient for whatever you want to do next. Now, in these two examples, the exponent on the variable was evenly divisible by the index. That won't always be the case. In this next example, we have the 5th root of x to the 17th. And we do want to see how many times does 5 go into 17. So we can do division. We can throw that into our calculator. And we see that 5 goes into 17 3 times. And then if we throw this into the calculator, we get some decimal. 17 is 5 times 3 plus something. Working it out, 5 times 3 is 15. What's left is 2. That's 17 minus 15. So 17 divided by 5, we would say is 3, remainder 2. And the way we figure out what that remainder is to say, well, multiply 5 times the whole number part, see what's left over. Okay, what good does that do us? X to the 17th then is x to the power 3 times 5 plus 2. Product of powers rule says that this is x to the power 3 times 5 times x to the power 2. So this is x to the third power to the fifth power times x to the second power. Why did we do that? Well, we want to rewrite the fifth root of x to the 17th. So we have the fifth root of x to the third power to the fifth power times x to the second power. And now we split that up. We have the fifth root of x to the third to the fifth multiplied by the fifth root of x squared. And now the fifth root and fifth power cancel out, and we're just left with x to the third outside of any radicals multiplied by the fifth root of x squared. And so that's what we get if we simplify that root. Do we need an absolute value? We do not need an absolute value. Why not? Because 5, the index of our root, is an odd number. Okay, one more example like this. We have the sixth root of x to the 17th. So 17 divided by 6, that's going to be 2 point something. So 17 is 6 times 2. That works out to 12. And what's left then is a 5. That's 17 minus 12. We had 2, remainder 5. X to the 17th then is x to the power 2 times 6 plus 5. And that whole thing is in the exponent. So that's going to be x to the power 2 to the power 6 times x to the power 5. And this time I applied the product of powers rule and the power of a power rule at the same time. So the sixth root of x to the 17th, that's going to be the sixth root of x squared to the 6th times the sixth root of x to the 5th. The sixth power and the sixth root cancel out, and I'm left with x squared, but I need to take the absolute value of it. We do need the absolute value because 6, the index of our root, is an even number. So I've dealt with the sixth root of x squared. I still have the sixth root of x to the 5th. Notice that we can only do this. We can only take out a factor that is a perfect fifth or sixth or fourth or second power if the power of the variable is more than the index. If the power of the variable inside the root is less than the index, we can't simplify any further. So if we're given an expression where the power of the variable is less than the index, we can't simplify at all. If we've gotten down to a point where the power of the variable is less than the index, we can't simplify any further.